Okay, now we're gonna look on percentage yield. Okay, so percentage yield is the ratio of actual yield to the theoretical yield obtained from the experiment multiplied by 1100 lah. So why we have percentage yield is when we do stoichiometric calculation, we calculate based on the moles, based on dia punya molar mass. We will get an example lah, contoh lah, as well at the end of the experiment kita akan dapat contoh lah equal to 2 gram mass dia. But in experiment we rarely get 2 grams. Okay, because sometimes masa kita nak buat titration tu tertumpah sikit lah, or our measurement is not 100% accurate, so that's why we'll get actual yield where sometimes we actually dapat less, most of the time less lah, maybe 1.98 grams like that lah. So that's why we have percentage yield. We are looking on how much of our end product from the experiment, okay, how close that we can get to the theoretical yield, the theoretical yang based on kita punya calculation. Okay, so let's look on this. Okay, contohnya soalan ni. So sodium chloride was formed with when 0.035 moles of chlorine gas reacted completely with sodium according to the equation below. Okay, so dia cakap it is 0.0345 mole. Okay, calculate the percentage yield of 3.75 gram of sodium chloride. So calculate the percentage yield if kalau at the end kita dapat 3.75 grams. Okay, first thing first, jangan terus buat apa, make sure balance ke tak. Balance dulu. Okay, balance. So if you look, sodium, yes, sodium satu ada belah kanan, belah kiri, and belah kanan pun ada satu. Chlorine ada dua, belah kanan ada satu. So darab lah yang belah kurang, so kita darab 2. Now sodium pula ada 2, while this ada 1, so kita darab. And then check balik, and then you tengok, so it is balance. Kalau dia dah balance, nice. Okay, now calculate the percentage yield if 3.75 grams of sodium chloride is produced. So first you need to look on punya theoretical yield. Okay, so dia punya theoretical yield. Okay, okay, so first kita tengok kalau based on the equation, okay, how many sodium chloride that we should get lah. So dia cakap sodium chloride form when 0.35 mole of chlorine to gas. So if you look, sini is 1 kan, sebab tak ada apa, 1 kan. So 1 mole of chlorine 2 you will get is 2 mole of NaCl. Okay, so if we have 0.035 mole of chlorine gas, okay, we should get darab and then bahagi, we should get 0.0690 mole of NaCl. Okay, so we got this. So for the theoretical yield, since dia bagi gram, kita compare dengan gram lah. So nak tukar kepada mass, okay, mass of NaCl that we should get is equivalent to 0.069 times, okay, sodium is 23, ada 1, so tak perlu darab apa-apa, tambah dengan chlorine is 35.5. So you should get it is 4.04 grams, right? Okay, so now let's barulah kita boleh calculate the percentage yield. So the percentage yield we can denote as percentage, and yield is equivalent to the actual, actual yang dapat daripada eksperimen, which is 3.75 grams over theoretical based on our calculation. So it is 4.04 grams, and don't forget to times by 100 lah. Divide. You should get 92.8%. Okay. So now kita dah buat in solid, we have buat in gas form. Now let's look in solution. Okay, so in solution we have few more equation that we need to know lah. So we have three, okay, and these three can serve you, can make your life easier lah. So one way, if you want to find number of mole, is using this is molarity, and this is volume. Okay, in dilution, take note that, okay, this is molarity, the volume, okay, for this volume usually kita akan guna milliliter lah untuk number of mole, usually bagi milliliter. Kalau dia bagi liter, you dah tak perlu dah bahagi dengan 1000. Okay, untuk dilution, one thing yang I need you guys to make sure is the unit sama lah. Kalau belah kanan milliliter, belah kiri pun milliliter lah. And this is titration, or you punya eksperimen 2 and also lab test untuk next semester. Okay, which is still the same, molarity, and V is the volume, and A and B is the stoichiometric coefficient. Stoichiometric coefficient. Okay, apa tu by A and B? So for an example is HCl plus NaOH. Okay, to titration this, you got NaCl plus H2O, and dia punya stoichiometric is 1 lah kan, dia tak apa, dia dah balance. So when the MHCl and then VHCl over dengan MnAOH yang VnAOH should be equivalent of dia punya stoichiometric, which is 1 kita dapat from the HCl and 1 kita dapat from NaOH. It depends lah, sometimes ada 2, sometimes 3, depends on dia punya stoichiometric coefficient. Okay, so let's see the example question. Okay, so now dia cakap magnesium, dia punya moles 0.06 mole of magnesium was added to 160 ml of 0.5 molar hydrochloric acid. Macam saya cakap itu, questions love to use M. M is mole per liter, which is molarity. Okay, so first is the question dia nak tanya is limiting reactant. So kita kena adalah the balance equation. So magnesium, dia cakap magnesium was added to hydrochloric acid, to HCl, and we get MgCl tambah dengan H2 gas. Okay. So now we need to balance the equation. So ni ada 2, so you darabkan dengan 2. So you darabkan 2. Now hydrogen dah cukup, chlorine pula ada 2, so you darab 2. Now it is balanced. So now, okay, dia cakap the magnesium is 0.06 mole. Okay, so untuk tahu limiting or excess, we need to know the reactants je lah. We do not care about the product. So how many moles of HCl? So NHCl, based on tadi number of mole, kita boleh guna mv over 1000, given that the volume is in milliliter. So kita ada dia punya molarity, which is 0.5 times dia punya volume, which is 160 milliliter over 1000. So you should get my calculator, you should get 0.5 times 160 divided by 1000. So you should get dia punya mole is 0.08 mole, right? So if you look at this, kita buat dia punya comparison. So this is mole given lah kan, mole given. So let's see. So 2 mole of magnesium will need 2 mole of HCl. Okay, if we only have 0.06 mole of magnesium, so we should only need 0.06 mole of hydrochloric acid. So if you look at this, N given of HCl is way bigger than N needed of HCl. This means that HCl is an excess reactant or reagent sama saja. So bila HCl is an excess, so magnesium is a limiting reactant. Okay, so that is another way untuk cari mole. Okay, now let's look on the second type of question. Okay, so ignore this. Calculate the volume of 0.16 NaCl solution to prepare 50 ml of 0.1 NaCl solution. In experiment 2 also ada this kind of method lah, where we call it dilution. Alright, so untuk dilution, okay, if you look at this, right, this GIF, where it shows that in a dilution, where you ambil dilution, the number of moles sama. So when the number of moles sama, M1, so dari nak cari number of mole is 1 MV over 1000 kan. So kalau number of moles sama, we just dilute it, sama, you should get the number of mole bila lepas diluted pun akan jadi sama kan. So there's no point of nak guna 1000 anymore. So you should be able to guna M1 V1 equal M2 V2. Okay, 1 is mean the before dilution and then after dilution. So if you can actually you masukkan the values. So let's use NaCl. NaCl is dia punya molarity is 0.16. Okay. Okay, and then volume dia kita tak tahu kan, volume NaCl kita tak tahu before, and then bersamaan dengan kita dapat lepas kita dilute 0.1 mole, and it is 50, kita dapat 50 milliliter. So when you bar the volume of NaCl should be darab 50 divided by 0.16. You should dapat 31.25 milliliter. Okay, lepas you dapat this amount, nak cari mole is, so mole of NaCl should equivalent of dia punya molarity, which is 0.16 darab dia punya volume 1.25 divided by 1000. So you should get 0.16 darab 31.25 bahagi dengan 1000. You should dapat 0.005 mole. Okay, so that's the final answer. So now let's look on the final question. It says 25 ml sample of HCl is titrated against Na2CO3 solution with 0.15 molar, and it requires 21.2 milliliters of Na2CO3 to complete neutralization. Calculate the concentration of the HCl solution used. So it is titration lah. Titration. So titration usually one thing you can take note of titration, you akan dapat water and type of salt. So first thing is always balance dulu. So you balancekan dulu this equation, you akan dapat that way. So kalau you tengok, so both side dah balance, so you can use the formula of MAVA equal MBVB equal stoichiometric coefficient A over B. So dia nak cari concentration of MHCl, while volume of HCl kita guna 25 ml lah kan. So kita punya 25 ml, so it is 25 ml, and then over the concentration of species lagi satu, which is Na2CO3, it is 0.150 times dia punya volume, which is 21.2 ml, and stoichiometric untuk HCl is 2, and Na2CO3 is 1 kan, so depan kosong ada 1 lah. So at the end, the concentration of HCl is equivalent to 0.253 molar. Okay.